Okay, I'm just going to say a few words then, just for those of you out there that don't know me or don't know the LJC or tuning in afterwards. My name is Barry Crumford. I'm the founder of the LJC, or the London Java community. I'm not a developer myself. I run a recruitment company called RecWorks. So our belief at RecWorks is that recruitment can be a force for good beyond just placing people in jobs. And specifically, that tends to be around mentoring and learning. So we see our work as sitting somewhere between giving back to people we've worked with in the past and paying forward to people that we hope to work with at one point in the future. And to put it simply, if people want to learn and people are happy to teach, then we're happy to be in the middle and make the connections and either create the platforms or the groups to make that happen. So this event today is part of an initiative that we have started to encourage a new diverse generation of speakers within the LJC and beyond. So we've always had new speakers come through the LJC. People like Jim Goff and Trisha G gave their first talks as lightning talks within the LJC, and hundreds of others have as well. So it's always been something that we try to push, but now we're really trying to get behind it and make it happen at scale. So this is a chance for people to practice, a chance to get feedback and everything else. So yeah, if you're interested in giving a talk in the future, come and see us. Or if you're just here to enjoy some talks for lunchtime, then please do, please enjoy. And obviously it's meant to be a bit light. It's not meant to be a heavy talk, so feel free to have kids walking by in the background and eat your lunch and whatever you may do. Anyway, without further ado, I'm going to hand over to our first talk, which is Grahame Oakland, with the ambitious role of 7 actors in 7 minutes. Grahame, go ahead.
Okay. Right, I think you might need to give me control of the screen, Barry. Okay, that looks promising. Let's have a look. Okay, can everyone hear me first of all? Can you hear me okay? Great, and you see my screen?
Yep.
All right, okay, we're good. Okay, so, oops. So my name is Grahame Oakland, but thanks for the introduction, Barry. I'm a kind of semi-retired Java programmer these days, with an interest in 1970s jazz fusion, as you can hear, and also 1970s research papers. So this is a heptaphonic guide through the actor model, and we'll try and spend the next 7 minutes whizzing through a bit of history. So the year is 1973. Globalization is everywhere. People are on the streets demanding change. Revolution is in the air. And that revolution is structured programming. So there is techniques for doing this, for go-to list programs and flowcharts. However, it fails to tell us how on earth did Herbie Hancock manage to release not 1, but 2 albums in the same year? Luckily, help is at hand. Carl Hewitt and a team of crack artificial intelligence engineers at MIT propose a model conceptually based on a single kind of object, and that object is the actor. Also, a Friday thought perhaps, programs should not only work, but they should appear to work as well. Doug Ross, he's not to be confused with the ER doctor that George Clooney played, calls for a single unified language for software engineering. Now, as far as I'm aware, the authors of the paper assume that you know Snowball 4, Planner 71. I've never heard of them. But what we have heard of, messages. Okay, let's have a look at an example. So actors can send messages to one another. Actors can create other actors. Actors can work in parallel and can send messages to each other and ultimately crash and burn. So the paper carries on, and as you read through it, there's lots and lots of Alice in Wonderland quotes, and also early duck typing, but most importantly, is a very promising model for parallel computing or parallel processing. Now, this is extremely helpful if, like Rashan here, you are required to have concurrent sax and nose flute abilities. So if you are someone who can play a flute, an alto, soprano sax, and a tenor all at the same time, this has got to be a good model. So guys, prepare thyself for a miracle. Salvation. That's actually the first track on that album. I thoroughly recommend it. So the paper continues on and deals with structure programming, deals with global state, which it considers harmful, no globals. And at the end of the paper, there's a litany of like the who's who of AI and computer science at the time. There's Bill Gosper, a data structure is nothing but a stupid programming language. Alan Kay, John McCarthy, Seaman Papert, Robert Milner, who then I think went to Edinburgh after that, Peter Landon, and even Dijkstra had a pleasant afternoon discussion. Something is up. However, not all was well, as witnessed by actors releasing albums. Could the worst be Danny Bonaducci from the Partridge Family? Or surely the biscuit taken? Burt Reynolds asked me what I am. Probably that was his only album he ever released. It was awful. So in 1973, in conclusion, fantastic year for the actor model, groundbreaking year for albums, but for actors releasing albums, probably a year best forgotten. Guys, that's all I've got. That was a whiz-bang tour through 1973 and the actor model. And here's a list of the tracks. The ELP track, you probably know it was released in 77, but apart from that, they're all from 73. So I hope you found that enjoyable or slightly entertaining. And with that, I'll pass back to Barry.
Brilliant. Thank you very much, Grahame. And I'll ask everyone unmute and please give a round of applause for Grahame for the first one. Grahame, I have to say that is that's the first time I've heard music in a lightning talk, and definitely the first time I've seen Burt Reynolds mentioned in a lightning talk. So well done for that.
All right, okay.
A few minutes before we go on to the next one, then. So Dom, have you sent around the link? I don't know if you have. Can you put the link in the chat, Dom, Carlo? So basically, part of these lightning talks, part of this these sessions is all around collecting feedback for the speaker. When you first start speaking, feedback is just so important. It's a key part of the Toastmasters group as well. So Dom should have just sent a link there. If you can just log on there, even if just 2 or 3 people can do it, but as many people as possible that can collect, just add some feedback, any positives there on there would be great. Any messages to Grahame, that would be fantastic. So we'll just have a few minutes before the, is it Sarah? I think Sarah, you're next up. So if you want to share your screen, make sure that's all working. I think I've set everyone up now as a co-host, so that should be easy. But yeah, I never knew Burt Reynolds released any music. So there you go. And then that's good. So this is different in stark contrast to usually where we're pushed for time. To have finished after 5 minutes is great. At 7 actors in 7 minutes, I thought that was never going to work. Although last week we had Pedro Lopez manage to squeeze 11 tips for remote meetings into 7 minutes. It can be done.
That's the advantage of having a Scottish accent, Barry. You can speak very fast, you see.
Right, Sarah, are you okay? You got the screen share up and running?
Yeah, I'm good to go.
Okay, brilliant. All right, well, I'll hand over to you then. I'll let you start a minute or so early.
Right. Well, I'm going to scale it right back. No slides, no music. Sorry. So my story is about how we ended up with a team lead who couldn't code, and it started off with us having three team leads who quit within weeks of each other. And there was obviously a problem here, and that's not our story today, but what we did about it. So I can come back and tell you that one maybe. But yeah, so we had all these people quit, and it wasn't that surprising. They had a lot on their plates. It was a really grueling job. They were looking after technical strategy, decisions, overview, tooling, practices, discipline, as well as product work and line management. And we had really, really big teams, at least for me. So teams of around 7 to 10 people. My team in particular was 8. And the reason we are this size is because we do look after all our own infrastructure, and we are on call. So it's nice to share that load. And you can imagine that line managing these people is a lot of admin on its own. So trying to do and be all the things wasn't really working. And it just got to a point where they ended up leaving. So what we did to combat this is we split the role up into a team lead and a tech lead. And my team ended up with someone who hadn't coded before. What they did have is they did run their own startup before, and they were used to delivering software products. They knew what AWS was and servers and all that, and we didn't have to explain that kind of thing. They literally just didn't write code. And the tech lead, which was my role, so I took on the technical direction, the practice, and I was a lot more available with the team because the team lead took on all the line management, team logistics, recruitment, logistics, admin, presentations, all that sort of thing. And it really made a massive difference to the team. They felt that they had people that were now a lot more dedicated to their well-being as well as their practices as technologists. So because I was able to spend more time with the team because I didn't have to do these extra things, we had a lot more focus on technical direction, and I was a lot more available and that kind of thing. So that motivation really, really helped the team. And yeah, the dedicated focus. So on their well-being, the team lead was able to spend a lot more time with people, talk about what they wanted to do, where they were going, and it didn't feel rushed. Our previous one-to-ones were useful, but really rushed. And it made all the difference. So I wanted to tell you about this because software is still very new. A lot of our roles are not set in stone. You know as well as I do that the title can vary a lot across different organizations. And I think that we can benefit a lot from taking people in from other industries and not necessarily training them on how to create software products, but learn from them and have them coach us. I got a lot from this. I'm a much better leader for having someone who was available to help me navigate certain situations that I just didn't really have experience with. And he had a much different perspective to me because he came from a different line of work, essentially. I've always been a developer, and it was really, really useful to have that experience. And we do have these people available. So you might wonder where we might get these sorts of people, but there are so many people who want to work in technology. They think that they have to take boot camps and go through boot camps to get into tech, and I don't think that that is true. So I wanted to come and plant the seed today and share my experience with you about what it was like to have someone who didn't necessarily have a technical background and actually made all the difference to our team in a leadership position. And then I'm going to soft promote. This is my Twitter handle. I am going to write a blog about this and publisher in July, Sarah and Usher. If you would like more in-depth information, pros and cons. So I can share that with you in July. That's it. Thank you very much.
Fantastic. Thank you very much then, Sarah. Thanks for that. Again, people, if you're happy to, then please feel free to to put some feedback down about Sarah's talk. I can't believe that this is flying by compared to one that we had where I think the first 2 or 3 talks took over half an hour. So yeah, but very good and very interesting topic. So what background did you say this person came from?
So they had run their own startup before. They hadn't actually gone through any formal training, and they had a lot of knowledge about how a company works, things that I think we're not necessarily exposed to as developers, especially if you work in a very large organization, things around budgets and interacting with other people who don't have a technical background and that sort of thing. So he knew what it was like to raise funding and, navigate difficult situations, awkward politics and that sort of thing. Not that we had a ton of that, but I think when you're trying to learn or navigate your way into a leadership role or management role, we don't provide people with training. We kind of just dump developers in and expect them to just lead people. And some people are not very good at that. But this actually allowed a situation where I was able to take on some leadership, but without necessarily people managing, and learning from this person. And it's made me a much better individual. So I likened this, I called it coaching captain. So he was very much like a coach. He was outside of the team, and I didn't really interact daily with the team, but he was able to really coach us through it. And I was the captain. So I would play with the team, if you know what I mean. That's the title of my blog post. I didn't mention any of this in my talk because I didn't think I would actually talk so fast. So clearly the nerves help speed up the speaking. But yeah, so I will write up a lot more in-depth stuff about that. Yeah. If anyone is keen. But yeah, we learned a truckload, and I would really suggest people think about this kind of option.
Yeah, very interesting. We're starting a new community at the moment for heads of people. It's called LHOP, London Heads of People, and we are exploring, because there's been a lot of interest from that side on heads of people not understanding developers, how developers work, and so we had an event on how to retain technical talent and that kind of thing. And it was fascinating, because obviously I've spent all my career on the technical side, hearing from people that didn't understand, and so there's so much that people can learn from going across different areas, I think. So yeah. Okay, cool. Thank you for that, Sarah. I really appreciate that. Ilan, you're up next. Are you ready? Are you screen sharing here?
I'm not screen sharing yet. Let's try screen share. Tell me when you can see my screen.
We can see your screen. You're good to go.
Okay, so my name is Ilan PILLEMER. I'm a human being. I'm on things. I am the only person with my name in the world, so if you're interested, you can just go find me. I'm not going to help you any further than that. Today, what I'm going to be talking about is an interesting paper I read about how OAuth 2 is being abused by collusion networks to generate millions of likes. If you want to get the full detail of the case study, it's available in the ACM Digital Library, and I've put the link on the screen here. I encourage people to go read it for much more detail. And also the AMC Digital Library is free until the end of this month. Part of the coronavirus thing, for some reason, they made it free. It's normally quite expensive. So if you want to go and get millions of different articles, literally, that are very, very interesting, get there before the end of June. Okay, so let's go to the next page of the slide. So I'm going to speak in the next 5 minutes about 5 different things. What reputation is, what this has to, how this can be abused, and why it's hard to detect. Why can we not just stop the abuse easily, because what's actually being done to do the abuse is legitimate. And then there's one solution that did work for the case study that I read. So reputation is quite important in social media. So fraudulent reputation results in disinformation, basically. If you posts are shown to more people, if you've got 1 million likes, for example, they're more authentic, they seem more real, and you trust it better. Just as one example, I know that when I use Amazon to buy books and I go to secondhand bookshops, I try and choose the ones that have had 99% with 100,000 users rather than 99% approval for 5 users, for example. So it definitely affects me when I use Amazon. It also results in information that's being spread and disinformation. We know, we've seen what's happened in the world lately, that it's bad for society. Now, in the paper, people that used this method discovered that they got 2.7 million likes on their posts in the case study when they used the collusion networks. How does this work? So if you imagine you had 10 million friends and you had an agreement with your 10 million friends that if you liked a post, if you asked them to like a post, all 10 million of them would like a post for you. And you create a network of collusion. Basically, you and 10 million other people decide you'll cheat the system, and you will share your passwords with each other, and you will allow that to happen. So that's in effect what's happening. The way that's being of OAuth 2. Now, with any of us that use social media or third-party, know that third-party applications can act on behalf of you. Something appears when you open an app. It says, will you give us permission to do certain things? The moment you've done that, you've given the permission to this app to post on your behalf. Now with OAuth 2, there's a number of different modes. The mode that gets abused is called the implicit mode or the client-side mode, which means that all you need is an access token and the permission scope. You do not need a secret. These access tokens, for example, on Facebook are valid for 2 months. So essentially what happens is you sign up to a collusion network. It then asks you to provide the access token to it. You give it that access token, and then it then goes and finds apps that can be abused in this way and uses them. It uses legitimate apps. None of the apps that are used are actually created by the collusion networks. They find legitimate apps. Apparently in the top 100 Facebook applications, for example, 50 of them can be abused this way. And they all have millions of users that are legitimate, and they're legitimate applications. Why is it hard to detect? Of these pools that get created by all these colluding people that sign up to these networks, which is simply going to a website and providing an access token, allow them to be able to use these pools in order to do the fake likes, but they can do it in such a way that rate limiting doesn't work, because they have enough tokens that they can spread the likes out across the tokens. And also just invalidating known tokens isn't enough, because they keep getting new tokens into the system. You can't use temporal clustering because they also spread this activity out over time. So why is it legitimate? It's legitimate because client-side operations are necessary. As they say in the paper, many Facebook applications solely rely on client-side operations for cross-platform interoperability and to reduce third-party developer costs. So if they were to stop this ability, millions of legitimate applications would just stop working. So what did work? In the end, IP limits by themselves did not work, because, for example, hoopla.me had 6,000 IP addresses that they could then just spread across so that the rate limiting didn't work. But they did discover that all the collusion networks were limited to specific autonomous systems. So then they could block those systems, and that did stop it in the case study with Facebook. If you want to find out more, go read this paper. I do encourage it. And as I said, my name's Ilan PILLEMER. I'm a human being. You can find me on GitHub and in LinkedIn and in probably other things if you try hard enough, but I don't use Facebook. Thanks.
Thank you, Ilan. Appreciate that one. And wow, 6 minutes.
Yeah, first time.
They're coming down.
First time I've made it within the time limit.
I know. That was really, really good. So what inspired you to choose that subject then, Ilan?
Because I found it interesting because I know I tend to trust stuff more when I see millions of likes on a post. I think it's probably true. If a million other people say it's true. But after reading this and discovering that simply by going to a place like flublar.net, and there are a couple of them, you can simply register, and within a day or two, you ask for a particular post to be liked. So you can say, this is my post I want liked, you submit it, and then within a day or two, you have hundreds of thousands of likes on your post.
Wow. The RecWorks social media is going to change.
And you don't even need to pay for it. The way it works is that these sites monetize it by advertising on the site itself, because to go to a site that provides a service to you, because it's a service, they put advertising on that site that they make money for, because millions of people go to these sites. And secondly, they add premium. If you want to have extra features, you can then, pay a little bit. Mm-hmm. And so basically for free, you can get millions of likes on a post. You can do it yourself.
With just likes, so you can get reposts, comments.
Yeah, it depends on the premium you're willing to pay. Wow. And how much of a fraudster you feel comfortable with being. Mm-hmm. But it's there. People are doing it.
Crazy.
Of other.
Ilan, losing you on the audio.
Some of the social media sites just don't care. Some of the social media sites don't care, so they just allow it to happen, and some try and stop it. So you've got to be very, very careful about trusting something just because it has lots of likes. So I wanted to put that out there, that read the stuff, get a better understanding about what's actually happening. Don't trust stuff so easily.
For sure. Okay, Dom's just put that link, reading my mind about what I was just about to ask for. Has just put that link down. So again, if anyone could leave some feedback for Ilan, just checking as well. We've already had 1, 2, 3, 4, 5, 6, 7, 8 different unique bits of feedback from you guys. So thank you so much. It's all really, really useful. Please do keep it coming. Augustine, are you ready? You set? Are you good to go?
Yeah, let me just share my screen.
Beautiful.
Yes.
Superb. Cool. Yeah, absolutely. Whenever you're ready then.
All right, brilliant. Thanks, guys, and thanks for giving me the opportunity to talk here. I'm going to talk about some of the stuff I've been looking at the past few weeks around exception handling in Java. So in Java, generally, a method's API is the value it returns and the exceptions, or the set of exceptions it may throw. And the clients that call that library can have to deal with those two scenarios. You have to deal with the value it returns or void, and you also have to handle any potential exceptions it may throw. And you have to do them in two different ways. You handle exceptions using the try-catch syntax, and you handle the return value like you would normally. So there are two separate ways of handling a method when calling it. A method could decide not to handle it. You could just pass on the exception and deal with only the return value. Or you could do both, where you handle the return value, you catch any exceptions your call may throw, but you also throw your own exceptions as well. So this is normal. This is the way exception handling has been working, and it works almost all the time, and we're all very happy with it and use it effectively. It can get a bit unwieldy, simply because you have these two ways of doing what could be considered the same thing. You're calling a method, you're getting something back, but because you have to handle exceptions differently, you have a scenario where you want to do something, and then if it fails, do something else, and if it fails, do something else. And when you could mitigate things like this by structuring your code much better, but from time to time, you do end up having ugly things that look like this, which isn't always great. Also with lambdas coming in as well, which is very, very good, and everyone's jumping on the lambda bandwagon. They don't handle checked exceptions really well. So you'd have to have like blocks of try catch in between your lambda calls, which works, but takes away from the nice fluent coding style that some people may like. So it would be nice if we had some sort of try monad that holds both the results for computations and potential exception to one value into a single container that we can then treat as a single thing, basically. And other JVM-based languages like Scala do have this. Java decided not to put this in, but they do have other monads in Java. The optional is one of them. And some of the requirements you need to be a monad is you need to basically use some sort of container that wraps a value. In the case of optional, you can wrap pretty much anything. Here, I just have an example where it wraps a number and integer. Then you need some unit function where you can create the monad from the raw value. So in Java, you can say optional off and give a value, and you get that container with the value inside. Or you can say nullable and give it some value, and if it's null, you get the wrapper with nothing inside. So you have this unit function where you can create one from nothing. And you need a bind function where you can compose functions together. So in this case, I've got one monad with a value inside, optional 14. And then I have what we call monadic function, a function that takes a value and returns a monad. And you can map these two together using the bind function. In optional, it's called flat map, but it depends on the type and what you can call. And with that bind function and that unit function combined, you can have all sorts of interesting other higher order functions you could have on the monad that lets you do many interesting things. But those are the three requirements that are basically needed. So it's unfortunate Java doesn't ship with that by default, but we could still think about what a monad would look like, and we could use libraries that actually do support that. So it should be some sort of container that wraps or encapsulates a computation. The result, it should contain either an exception or it should contain the value of that computation or void if it's nothing. And you should have a function to create those tries. You should have some sort of bind function where you can chain various methods together. And with those two, you can then have other higher order functions that you could use to make your code really nice and neat. So our methods now look like this. Instead of throwing exceptions, we'll just return a try of some type. In some libraries, you have to specify the exception types as well, but in some, you don't. Just assumes there is some throwable in there. So when you say try or string, it's implicitly understood to be either try with the value in it or try with some exception in there. So you would have a monad, like you'd have a unit function like this, where you pass in some computation and it will return try with the value in there, or you pass in some computation that throws an exception and it will return the try with the exception in it. The two libraries I looked, most libraries have this structure. You have the try itself and you have two subclasses. One is a success and one is a failure. And what you get will be determined by what the result of running your value or your exception is. So I looked at two, but they're much more. I'm not sure I'll have time to look at both two, but I'll just skim through the first one and we'll see how. Okay, yeah, I don't have time to go through. So the first one is vavr.Try, vavr, I don't know how to pronounce it. And you can create it like this. So you can say try.off and pass in your computation. You get a try of an integer or whatever that value returns. You can do try of success and you get a try of that value. You can do try of failure, pass it an exception and you get a try back. You can do try of run, pass it a runnable and you get some value back. And you can inspect a try. So say you call some function and return the try, you can have a sneak peek and see what's inside. You can do get and that'll get you the value. You can ignore the error and do or else and give you an alternative value. You could get the error itself by doing get cause, or you could check if it's a failure or if it's a success. It works really well with streams. And that's the reason, this is the main reason why I was looking at it, because we do lots of computation on collections and streams, and you have this fluent functional way of coding, and we don't want to have try catches in there. So in this case, I have a stream and you can do map, pass it a try, and then from line 3 onwards, you just have try. So you can filter on them, map them, collect them. And this is much nicer than having try catch blocks in there. Same thing with mapping exceptions. So you have a try catch. Instead of having a try catch, you can just use map failure in this scenario. And that initial one I showed you about, the initial example where you have nested tries, it now just flattens out into a set of method calls that looks like this. So it's quite nice, it's quite neat. It makes the code look cleaner, and it is good sometimes to think about it that way. Instead of handling exceptions differently, we can handle them the same as normal values, and these libraries help us to do that. Thanks.
Thank you very much, Augustine. Really appreciate that. Brilliant, thanks for that. And nice and just within time as well.
Yes.
This is good. Dom, this is good. This is good. This is all keeping everybody's within the in the 7 minutes. Damien, no pressure on you to do that for the clean sweep this time. Are you all set? I think if we can just have a few minutes as well, just to collect a bit more feedback. Dom, if you wouldn't mind putting that link back up, if that's okay, or it's quite recent anyway. But yeah, and also afterwards we'll send the link out. In fact, you should have had it already in the emails that you got with the Zoom link. Yeah, if you have a chance to, if you haven't quite put all your feedback down, if I've been putting the next talk on too quickly, then yeah, please do send it through afterwards. I think we got something like 25 or 30 different bits of feedback from the last set of talks. And again, the amount of like the people that get that feedback, obviously it's so good. I think when you start talking, I know we've got a combination of people that are experienced and first timers today, but when you do first start and you have no idea how it's received, it's so good to be able to see people pick out the specific good points that they liked, and if there are any things that might make it a bit better, then it's useful to improve. But no, I implore you as much as possible, just even if it's a few lines, a direct message, anything like that, then please do pop something down. Okay, I'll give it one more minute then, and then Damien, you're all good, right? You're all set, ready to go, and you're giving a full talk to us soon. Is that right? Have I?
Maybe we have to work that out, but yeah, there's a
Nice.
couple of interesting topics to talk about.
Brilliant. Okay, well, if you want to go ahead then and share your screen, I'll get the timer going.
All right.
Brilliant. Ready to go whenever you
So
are.
you can all see that, I assume. You just get my timer started. Cool. So Damien O'Connor is my name. I was a Java developer once upon a time for a couple of years. Do different things now. What I want to talk about today is, if you think about early 1900s, this picture was taken in a factory set in northern England. It shows we've got a number of different people working on either side of a conveyor belt. We've got specialists, so doing some specialist role. They put their finished product onto the conveyor belt. It goes down, and the next person in the chain picks it up. And then you can see a bunch of people standing around who are waiting for the end product. So or their managers, or I guess you can try and pick out the managers because they're the ones wearing ties. What we can see is that this was the way that factories worked, and this influenced a lot of early software development. And this was the context in which Melvin Conway here wrote his paper. In 1967, he wrote a paper that described the relationship between an organization's structure, the org chart, if you want to call it that, the communication networks that existed in that organization, and then that resulted in impacting the architecture of the product that they made. Now, they weren't making software back then, they were making physical products, but this actually flows onto the software world as well. And so what he's effectively established is you set your organization structure up a certain way, that's going to influence your network of communication within the organization, and that's going to influence the structure of your software. So what do I mean by network of communication or communication network? So what you can see here is a fairly generic organization structure, and the black lines represent the communication lines between different people in that company. And as you can see, some people don't talk to anyone. So some people in the green area are isolated from everyone else. And there's this one person in the middle here who's very popular, obviously gives out free beers on a Friday, and he or she is talking to a lot of different people. And that's what I mean by communication network. So it's an informal network of friends or colleagues that like to talk, and that will influence the software structure itself to a large degree. So what do I mean by all of this? So I wanted to give you a couple of examples. We had small distributed teams. They're more likely to produce modular service-based architecture systems. Whereas if you think back in the early 70s and 80s, they probably had large co-located teams, and they produced a lot of monolithic software. And obviously everyone, I would imagine, is of the same opinion that monolithic software is, you know, more complicated, it's harder to maintain and more expensive to extend. So in those ways, it's undesirable. So what do we do about all of this? We've got one option, which we effectively reverse engineer our system architecture or application architecture and design our team structures to be the same way. So what you can see here is we've got 4 teams, each comprised of front-end and back-end devs. And then we have a shared service in database and operations. And if we set our teams up that way, we're more likely to get an application structure like this. So we've got 4 different applications, each with a nice discrete UI and application tier, or API if you want to refer to it that way. And those APIs all interact with a core shared database, but you know, beneath that. Now this is all lovely, this is all great. What if we zoom out to the company level, and we've got, on the left-hand side, we've got the environment the companies are working in. Their leaders of that organization will come up with a business strategy. And that business strategy can either fit or not fit with the organization structure internally. And by organization, I mean not just the structure, I mean the people who are in there, the culture that they share, and any critical work that they need to do. And if that structure and the strategy match and they fit and they work well together, we get good performance out the end. If they don't fit, we do get a bit of a problem. We don't get as much performance from the team. There's a bit of a tongue-in-cheek joke here about the different structures of different organizations. I think as an outsider, we've all got a feel for what maybe the corporate culture within some of these organizations might be like. And you can start to see that there's some interesting jokes there particularly around Microsoft pre Satya Nadella joining, or taking over, I should say. I've given you a bit of an insight here into what GitHub did when they first started. They designed their organization based on the principles around what makes successful open source projects. And they took that and they said, we're going to design our organization to leverage these principles and really, you know, make sure that we can do the best for the environment that they were working in, which was obviously trying to help teams and individuals with their source code control for open source and other projects. Last piece is, if you're interested in this topic, there's a nice book that goes on, that goes into more detail about it, about Conway's law, about the relationship between org structure, communication networks, and application architecture. And if you're interested in that, you can always grab a copy of that book and have a read. And that's it from me. Thank you very much.
Brilliant. Thank you very much, and Damien, appreciate that.
No problem.